Hello and welcome to Science After Hours. In this lecture we are not going to have a lecture, we are going to go on a journey together. Because it's already been quite a journey for me, and now I'm imparting that journey onto you. We are going to make a tier list. I like watching tier list YouTube videos and I thought I would try my hand at making one. What could I possibly make a tier list YouTube video about? Well, in my mind's eye, making a tier list of all the elements of the periodic table. Here they are here, all 118 of them in their glory, was a fantastic idea. Until I realised I'm not a chemist or a physicist. I am a simple biologist. So I had to make an extortionate amount of notes on every single element. And here they are here. They don't have a ranking yet. That's all going to come off the cuff as it flows through me and onto this ranking here. We've got S, A, B, C and D. S being the best, D being the worst. All 118 elements are going to be subdivided into that. We can see at the end if we have some sort of normal distribution for those data fans out there. Because I know there are some of you. These are the elements here, all 118 of them. As I said, they are not ordered in the periodic table here. So if you don't know what the periodic table is, Dmitry Mendeleev in 1869 came up with the periodic table as we see it today, where the elements were ordered by their atomic mass. So you can see here, I don't know, cesium has an atomic mass of 55, radium 88. This is the weight of the element based on the protons and neutrons. They both have a weight of 1 and are equal in number in the stable element. The same number of electrons is the same number of protons to keep the element balanced. If you have too many electrons, it becomes a negative ion, like a Cl minus. If it's got too few electrons, it'll become a positive ion, like magnesium 2 plus has lost 2 electrons. It's got too many protons for that balance to be neutral. But if it lost 2 protons, it wouldn't be magnesium anymore, which is why it's magnesium 2 plus and not whatever element 10 is, which is showing my chemistry knowledge. Neon here. I am a biologist. We're going to get to know each other better on this journey, because goodness knows how long this is going to take. I have made a number of notes, as I said, on each element. Some of them are fun facts, some of them are just boring facts. I've realised a lot of the elements, let's say, if it's not a normal distribution, it may be skewed towards the C and D tiers. But let's not spoil the journey ahead. The elements here are ordered in their electron shells. So I've moved helium from the yellow ones here to the blue ones up here. So these are the S shell elements, where the S shell is the outer shell. Electrons are they flow around the core of the element in a sort of nebulous cloud. But this nebulous cloud, to help us understand it, can be subdivided into different energy shells. And these dictate the periods that the elements are in. Because obviously if you look at the periodic table, it's not just a complete square. So the ones with an S shell on the outside are these blue elements here. Helium is also a noble gas, so it has a full outer shell. So it is, when you look at the periodic table, grouped over here in the P section, because the other noble gases have a full outer P shell. So these yellow ones are the P elements, but just know that helium has no P shell electrons. Its electron configuration is 1s2. So it's actually an S element here. That's why I've moved it with the blue ones. We have the D elements here, which are in red, and then the F shell elements here. Again, these are all based on different energies. If I was a chemist, I would talk about how the D shell and the S shell, you can have 4s but 3d, because the 4s electrons have a slightly lower energy than the 3d electrons. But we're not getting into a lecture about electron structure. We are here to rank the elements based on my whimsical opinion at the time when I pick them up. I also have a whiskey coke here to help me get through this endeavour. And as I say, we're going to learn a lot about each other here. This is by far and away going to be the longest video I've made, possibly ever. Good luck, and hopefully I'll see you on the other side. But for those of you that are here just for the beginning, let's start with the lightest element of them all. Element number 1, hydrogen. Just a proton and a neutron and a single electron. What can I say about hydrogen? Well, first of all, it's going in the S tier. We are going straight out the gate, right at the top, because as a biologist, hydrocarbons are such vital things for existence. You can't have a hydrocarbon without a hydrogen. It's an energy source. We are pivoting more away from fossil fuels now. Hydrogen energy is a possible viable alternative. The problem we have now is that the production of hydrogen energy is bad for the environment. So once it's in the car, great. It's getting it from the planet into the car, not so great. But hopefully we can improve on that. Hydrogen is what makes an acid an acid. As I say, a single proton is an H+. The more H pluses you have in an acid, the stronger your acid is. Together with oxygen, it makes an OH-. That's what makes an alkali. So the whole acid-base system is dependent on hydrogen. It's going in the S tier. I won't hear anything bad about hydrogen. Helium, the first of the noble gases. The noble gases are a bit dull because they have a full electron outer shell. They're fairly inert and unreactive. I suppose the most common thing people know about helium is if you breathe it in through a balloon, because it's lighter than air, it makes your voice high pitched, which is fun, but we are currently partaking in a bit of a helium shortage here on planet Earth. Currently we seem to get a lot of our helium not as just raw helium from the air, but it's tied up with natural gases underground due to radioactive decay. So radioactive decay in the form of alpha particles, they are elements of helium with a few more protons attached. That's how we get a lot of our helium, and extracting that is quite energy intensive. So how much do we really care about balloons that are lighter than air? Don't know. But if we ever enter the glorious age of space travel, that might solve our problems, because helium is the 24th it's the second most abundant element. 24% of the total elemental mass of the universe comes from helium. So it's got some pros, it's got some cons, so therefore I think helium should go in the B tier. Lithium, important as a drug. It's a mood stabilizer because it interacts with sodium potassium ion channels, because it has a similar electron structure to sodium, which is directly beneath it. It can fulfill that sodium space in those ion channels, which is quite important for those that suffer with bipolar and other mood-based disorders. It's the least dense metal, as you might imagine. This is only element 3, so it's not going to be a very heavy metal, is it? It's used in lithium ion batteries, which are rechargeable batteries. That's a bonus. But otherwise, well, I suppose I haven't really come up with any cons. It's a bit boring, I guess. But how much do I... helium had actual cons in that its extraction from the planet is quite energy intensive. Is that equivalent to it being boring? Yes, lithium is also going in the B tier. Beryllium, element number 4. It only occurs naturally as part of a compound, so we have to extract pure beryllium in the form of from something else, whatever beryllium is bound to. So beryllium copper alloys are actually quite good in the steel making industry, it turns out, because beryllium copper alloys are very strong and they don't spark when you hit things with them, so no risk of fires. So that's a common use of beryllium. Beryllium dust turns out very toxic. In fact, it's so toxic it even has a name, and that is berylliosis. It's a lifelong allergic disease. That's quite bad. Beryllium can go in the D section. Number 5, element number 5 is boron. Boron is going to be down here in the P elements. Here it is, our first of the P elements. It's a real P element, not helium, which is over here. We're not going to go through that again. It's not really necessary for mammalian life. Only a tiny bit is required for plant life. And that's really all I've got to say. So lithium is a bit more exciting than boron. You know what, boron also going in the D category. D, boron, boring boron. But worry not, avid viewer, because the next batch of elements are all top tier winners. So element number 6 is carbon. It's going straight in S. No, we are carbon based life forms. We wouldn't exist. You wouldn't be watching this YouTube video if carbon didn't exist. It's part of hydrocarbons. We've got the hydro part here. Here is the carbon part. Diamonds are made out of carbon. The oil and coal that we unfortunately use to power our modern lives, that's got carbon in it. Photosynthesis relies on carbon dioxide, and that makes oxygen from plants. We need oxygen to live. Carbon. It deserves its spot in the S tier, and I won't hear any more about it. Number 7 is nitrogen, which is here. Now, 78% of the Earth's atmosphere is nitrogen. It's good for the soil in the form of nitrates. In fact, there's a whole nitrogen fixation thing that bacteria do. That's quite important. It's important for human beings. There are a lot of nitrogen containing compounds that are vital for life, and most of those are amino acids. They contain carbons and hydrogens, also oxygens. Spoilers, is the next element, but I would say it's not as important as hydrogen and carbon, so nitrogen can go in A. Oxygen, as I said, element number 8, it's going in the S tier. What is there to say? Oxygen, we need it to live. It makes up water. Glucose, you know, people like sugar, that's got oxygen in it. It's also in amino acids. Oxygen. These 3 elements here, your hydrogens, your carbons and your oxygens, they are the trifecta of biological life here on planet Earth, in my opinion. They all deserve their space in the S tier. Number 9 is the first of the halogens, which is fluorine. Here it is, fluorine. It's not my favourite halogen, so it gets minus points for that. Fluorocarbons, especially chlorofluorocarbons, are very bad for the planet. A sulfur with 6 fluorines attached to it is the compound with the highest global warming potential of any known compound currently in human existence. Obviously, global warming, very bad. So I think that should skew your fluorine down to here, maybe in the D tier. But then fluorine is also part of fluoride, which is good for teeth. We put fluoride in our toothpaste and in our water to help protect our teeth, so maybe it should go in the C tier. Fluoxetine also gets its name from the fluoride that's in it, in the carbon fluorine bonds that can be found within the drug, and SSRIs are an important part of life for many. So I don't think it's as bad as beryllium or boron, which are boring. At least I've had more to say than either of those. So that can be our first C tier element. Neon, the second of the noble gases, number 10, is here. So say noble gases, quite dull, they're unreactive. I suppose the thing most people think about neon is it makes cool lights. Neon is highly volatile, which is why it makes those cool lights, but it also is what makes those cool lights quite expensive. How much do we like cool lights? When combined with helium, it makes a red laser, which is cool, I guess. But noble gases are just a bit boring. Helium is the best of the noble gases, and that's in B. So it's not as good as helium, it's going in the C section. Sodium, we're back for the blues, we're back in the S tier of elements, in the S shell. Sodium chloride is salt, that's quite important. Most people like salt on their chips and whatnot. It's important for action potentials, so as the signal leaves the brain and travels down nerves, there's a change in sodium-potassium ion channels which transport the electron signal to wherever it needs to go. There are sodium-potassium ion channels in almost all organ systems of the body. I think that makes sodium, we wouldn't be able to function without sodium. So I think sodium can go in the A section. Element number 12 is magnesium. The thing I know most about magnesium is from my school days. We did at open days, we would do this thing where we would set magnesium on fire and it produces this brilliant white light, and that was to hopefully encourage people to come to the secondary school. Our secondary school was quite popular, so I guess that was a successful thing. So maybe magnesium should go in the top half. Magnesium 2+ ions, they are an important cofactor for many enzymes, especially in the human body, but also for plants. So the porphyrin ring is a chemical structure. In humans, the porphyrin ring at the center of it is a iron elemental group, and that is what makes up heme, which allows us to transport oxygen around the body. But we're not talking about iron. But in plants, magnesium is at the center of this porphyrin ring, and that's essential for photosynthesis. So I think magnesium can go in the B section. I've been hovering it around B the whole time. In B it goes. Aluminium, element number 13. Unlucky for some. For me, it loses a lot of respect for how Americans pronounce it, because aluminium has got 2 I's in it, not just one. So automatically I'm putting it straight down in the C or the D section. I'm sorry. It's common in the environment, but aluminium salts don't really have any biological purposes. It's not really that important for life. So C. Aluminium can go in C. Next up is silicon, and there's no doubt I think that can go in A. We are currently living in the silicon age, which is the computer age. Silicon is important for our life. This MacBook Pro that I'm making this video on, that's got a whole load of silicon in it for microchips. Also, if you're into the thoughts of extraterrestrial life, you know, as I say, we are a carbon-based life form, but there are thoughts that perhaps other life forms might be silicon-based, and that's quite exciting. So silicon can go in A. Next up is phosphorus. Phosphorus here. Element number 15. We have a long way to go. 103 elements to go. It's essential for life. It's in your DNA, your RNA, it's in ATP, which is the energy currency of the cell. Cell walls are made up of phospholipids. The phospho comes from phosphorus. It used to be the, matches, before they were safety matches that you had to strike against the edge of the matchbox, and you could just strike them against your beard or your coat or whatever. They were made out of phosphorus. That's quite cool. should it deserve a spot in the S tier? I mean, DNA has got a phosphorus in it. Oh, but phosphorus is also used to make white phosphorus, which is very bad. It's a banned chemical weapon if you don't know, so maybe phosphorus would lose a few points for that. B. We'll put it in the B section. I'm going to take a sip of a drink before we move on to one of my favourite elements, which is sulphur. Sulphur is one of my favourite elements due to the nature of a chemical bond it can make. The disulfide bridge, it's two sulphurs bound together with a double bond. It's what makes cysteine my favourite amino acid. It's got this sulphur-sulphur disulfide bridge double bond in it. But I'm not going to put it in the S section. It can go in A because sulphur smells bad. Everyone knows that. You read a book about something and if something is burning, it's usually described as sulphurous. And you can picture that in your mind and you know instantly that it smells bad. But I really love disulfide bridges. I love cysteine, so I think it deserves its spot in the A tier. Number 17 is chlorine. Another halogen, probably the most famous of the halogens, I would say. It certainly loses points for, how bad it is for the environment. It goes in. There's a reason we put it in public swimming pools. Because it smells bad. That's how you know you've been to a public swimming pool. But it's a powerful disinfectant, and that's good. But otherwise, chlorine has got a lot of bad traits. But for the same reason, it's a powerful disinfectant. You wouldn't really want chlorine to escape into the world. In fact, chlorine can be used as a bioweapon as well, and that's bad. And I did, phosphorus did lose some points for being able to be used in a bioweapon. Is white phosphorus worse than chlorine? I bet that's not a question you thought you would hear today on a YouTube video about elements of the periodic table. Let's just not settle that debate and put them next to each other in the B tier. Argon, another noble gas. 18. Let's say noble gases are boring. Neon is here, helium is here, it's going in C. There we go. Sorry, argon. Number 19 is potassium. We'll be back here with the S shell elements. We talked a lot about sodium-potassium pumps. That makes them very important. My favourite fruit is a banana, and that's got a lot of potassium in it. So potassium can go in the A tier. Next up is calcium. Bones made out of it. When you think of bones, I think of Petit Filou. Remember the adverts where there were the two kids arm wrestling and the one eats Petit Filou. It's like, Petit Filou makes your bones grow stronger. It's got calcium in it, encourages calcium. It's also an important ion for cells, not just because bones are made out of it, but it's important for muscle contraction. It's an enzyme cofactor like magnesium. It also acts as an important second messenger for a lot of biological signals. So I'd say calcium deserves an A spot. 21, scandium. First of the D elements, the first of the transition metals. Now I think the transition metals, all of them, with a few exceptions, bit dull. When you think of elements, you're not like, oh, do love those transition metals. So I think we're going to see a lot of red in these bottom two sections. Scandium is going to set the tone for that. Aluminium scandium alloys improve the nature of the compound, is what I have written here, compared to just aluminium alone. So therefore that suggests that scandium is better than aluminium. So should it go in the B spot? Radioactive scandium is used in oil rigs as a tracing agent. I've only got 2 bullet points for scandium, which suggests it was quite a dull element, so it can go in C, the same as aluminium. Next up, titanium, a more famous of the transition metals. It's going to be somewhere around here. Here it is. Aluminium titanium alloys are better than aluminium scandium alloys, I've written here. And they're also cheaper. And I like a good deal, so titanium can go here. It's also used in surgical instruments for its combination of strength and lightness. And as someone that's had surgery, I appreciate that. It can also be used to store nuclear waste. And as a proponent of nuclear power, one of the major downsides is, of course, nuclear waste. So methods of storing it are important. Titanium can go in the B tier. Vanadium, element number 23. Vanadium compounds are often used as catalysts in commercial chemistry. Well, that makes it sound thrilling. I'm sure I had a lot of fun reading about vanadium. It can go in the D section, and that's note paper number 2. 24, chromium. Chrome's made out of it. Chrome is shiny. It doesn't corrode. It's part of makes stainless steel. It's highly polishable. It reflects up to 70% of light, and that's why people love chrome on their cars. Chrome, C for chrome. Chromium can go in the C section. Manganese, number 25. Potassium permanganate looks nice, is what I have written here. As you can see, I'm going to include a picture of potassium permanganate. Yeah, looks alright. It's important for the body for some enzymes. It's important for bones, I've written here, and it's also important for protection against reactive oxygen species, which are bad for you. So I guess manganese can go in B. Next up, iron is an element that actually people know and care about. It's got an age named after it, the Iron Age. We talked about heme earlier when we were talking about magnesium and porphyrin rings. We won't be able to breathe without iron. It is the cheapest metal, but it also rusts, reacts with oxygen to produce iron oxide. That's what rust is. But we wouldn't exist without iron. Iron can go in A. Next up, cobalt, number 27. So vitamin B12, one of the essential vitamins, has got cobalt in it. And as a biologist, all things biology automatically bump an element up to the top 3 sections. Cobalt is also a useful gamma ray source, I've written here, for radiotherapy. It's responsible for one... Oh, that's right, I remember that. So it's used a lot in radiotherapy, and in the US the radiotherapy machines were not disposed of correctly for a while, and they had all this radioactive cobalt in it, and that was responsible for a very bad radioactive contamination. So whilst it is great that it's being used in radiotherapy, cobalt can lose a few points for destroying the planet. It can go in the C section. Nickel, found to have been used as far back as 3500 BC. Well, that's exciting, isn't it, that the ancient man found nickel. Very useful. It's used a lot in coins, also used in stainless steel. And those are all pretty boring facts. It can go straight in the middle, B. Copper. Copper plus tin makes bronze, and we have a Bronze Age. So I feel like you should get bonus points for that. It's a highly electrically conductive element. We use copper wires everywhere. It's important for the function of cytochrome C oxidase, which is essential for respiration. So it gets major bonus points for that. Iron is important for breathing. Oxygen is important for breathing. Copper, also important for breathing. It's part of the electron transport chain, so it can go in the A section. Next up, zinc. Zinc, number 30B. Zinc ions are important for a lot of enzymes, I have written. Zinc deficiency has many widespread effects in the body. Kind of wish I'd made more thorough notes, because past me, I'm sure those widespread effects on the body are very bad. zinc deficient plants are more likely to be diseased as well. So zinc can go in C, I guess. Gallium is here. We're back in the yellow section. Gallium alloys are used as a safer alternative in thermometers instead of mercury. We'll talk about mercury later, but mercury is a much cooler element, so it's not going up here in the top. When you think of elements, you're not like, oh, gallium is my favourite. It is used a lot in electronics, and it is considered a technology critical element. That's a term we're going to hear quite a lot because it came up quite a lot in my research. But it can go here in the C section because why not? Germanium, B, is a semiconductor, and the first decade or so of semiconductors were germanium based. And we use semiconductors a lot in our modern world, so props to germanium for being the first. So that does make it another technology critical element. It's also used in fibre optic cables. So copper is up here, and copper cables are sort of slowly being phased out due to fibre optic cables. It's also used in LEDs and solar cells. So I think germanium and copper can go hand in hand, sort of like the father and the son, so to speak. Next up is a much less fun element. And you'll know what I mean because it's arsenic. Arsenic is probably the most famous poison of all the poisons. I feel like it should go in the D section just for that. It's also used in pesticides, herbicides, insecticides, and therefore is terrible for the environment. It's not only being terrible for the environment and terrible for you because it will poison you. If you survive arsenic poisoning, you're more likely to get cancer because arsenic is a carcinogen. I have no idea how long it's been, but we're only on element 33 and I am having a great time. Number 34 is selenium. Selenium is going to be somewhere here. Somewhere, there it is, selenium, right in the middle. Selenium, it used to be important in electronics, but it's now mostly replaced by silicon. And silicon is up here. As I say, we're in the silicon age, so it can't be as good as silicon, so it's got to be B or less. But it is an ingredient in many multivitamins. But a high dose of it, if you take too many multivitamins of selenium, is highly toxic. So it can go in the C section, I think. Next up, we're back to the halogens. It's bromine. Bromine is here, element 35. It does have a niche use as anti-epileptic drugs. So that's important for people that suffer from epilepsy. It's also an important fire retardant. So that's good for people that don't want to have their house burned down. It's also an orangey brown colour. But it can't get too many points for that because of a different halogen that we will talk about later. So bromine can also go in the C section. Next up, element 35, the next of the noble gases, and the first element that's going to get a lot of bonus points for something that's got absolutely nothing to do with elements whatsoever, and that's krypton. Krypton is going in the A section because it's Superman's home planet. That's it. Otherwise it's a noble gas and it's quite boring. In fact, I think putting krypton here is a besmirchment to how important these other elements is. So krypton can go, sorry krypton, you've been demoted down into the B section, but major bonus points for not being in the C tier like all the other noble gases. You're as good as helium because of your name and your name only. Next up is rubidium. If you've been following along, you know once you get to a noble gas, you're at the end of the periodic table, so it's time to start a new S shell with rubidium, element number 37. It's ever so slightly radioactive. It's not radioactive enough to get a radioactivity symbol on this tier list. Rubidium 37 has a half-life of 48.8 billion years, which is 3 times the age of the universe. So it is quite good in atomic clocks. It can also be used as a biomarker, as it can replace potassium in living organisms, but it also goes into purple fireworks. I don't particularly like firework displays. I find them criminally dull. They go on for far too long, so it's not getting too many bonus points. If you like fireworks, rubidium can be higher on your own tier list. It's going in the C section. Strontium. On the firework train, strontium is used in red fireworks. It also used to be used in the glass of CRT TVs. So I guess if this tier list was being made, I don't know, 60 years ago, strontium would be right up here as you watched your CRT TV and played your NES underneath of it. Strontium aluminate is what is used in glow-in-the-dark toys. I had a lot of glow-in-the-dark toys as a child. I used to have those glow-in-the-dark stickers that I put on the ceiling to make a little starry display. And for that bit of nostalgia I've just conjured up, it can go in the B section. Next up is yttrium. We're back in the boring transition metals, so we already know it's going to be one of these ones. What have I written here? Oh, it has medical uses, so actually maybe not as part of alloys. That's all I've written. It's got medical uses as part of alloys. So yttrium by itself, I guess, is not particularly great. It used to make red in CRT TVs. So the cathode ray tubes, if they were coated in yttrium, a yttrium compound, that would produce the red colour. Thrilling. It can go in the D section. Next up is zirconium, number 40. Zirconium dioxide is a common diamond substitute. And, you know, diamond made out of carbon. Carbon is up here. It's an S tier. Does this mean zirconium is going in the S tier just for that? Absolutely not. Of course not. It's a transition metal. It can never get up that high. Zirconium carbide is used for making strong drill tips. You might have heard of diamond tipped drills. Obviously diamonds are a lot more expensive, so making them out of zirconium is much cheaper. Zirconium catalysts are useful in the production of polypropylene, which is the second most common plastic. So those are pretty good traits. It can go in the middle in B. Next up is 41, niobium. I think I've made a mistake here in that I have written my notes on very small bits of paper. So, niobium used to be called columbium until 1949, and this was due to confusion between isolates of niobium, tantalum, and columbium, which was then found to be niobium. Now, I do like a bit of scientific controversy. In fact, one of the first YouTube videos I ever made a few years ago was about some scientific controversies. I think you should get some bonus points for that. It can go in the B tier just for that alone. Next up is the first element with a stupid name, molybdenium. It's an essential element for eukaryotic organisms, so despite its silly name, it does get major bonus points for that, as it's an essential cofactor for many nitrogenase enzymes, and nitrogenase enzymes are crucial for life. It's also, remember I talked about those nitrogen fixing enzymes in bacteria? They also use molybdenum as a cofactor, so I think it should go in the A section. Why not? Technetium is next, element 43. In fact, looking at this, maybe I was a bit harsh on the transition metals. We've already got 3 up in the A tier, most of them in the B tier. They're not actually interesting. We'll see how this turns out. We are seeing a bit of a normal distribution, so that pleases me. Technetium, it's the lightest element where every single isotope of it is radioactive, and you can see here that it has that radioactive symbol. It's the first properly radioactive element that we are seeing on this tier list, so well done Technetium for that. Between 1828 and 1937, it was erroneously discovered 6 times. Now, we've already talked about, I love a bit of science controversy, so 6 times in over 100 years, people thought they had discovered technetium, but they had not. Because of its radioactive nature, more than 50 radiopharmaceuticals are bound to technetium, and that's because it has a half-life of only 6 hours, so most of the technetium can be will be released from your system very quickly. I think within the first 24 hours, over 90%. And that's a good thing. So it can go in B. Ruthenium, number 44. It belongs to the platinum group of elements, so it's fairly inert. Those metals are not known for their reactivity. If gold, platinum were all very radioactive, all very reactive, they wouldn't make for good jewellery. It is part of Grubb's catalyst, which was a Nobel Prize winning discovery and is used in the synthesis of alkenes. So they are things with a carbon-to-carbon double bond in them. If it was helpful in winning a Nobel Prize, I feel like it should get at least an A or a B tier. It does have a major use in the hardening of electrical contacts, I have written here. So I guess that is the clips and things that hold electrical substances together. That's quite important. It can go in the B tier. Number 45 is rhodium, not to be confused with Rhodians, which are the Greedo-like aliens in Star Wars. No, this is rhodium. It's often used to plate white gold and silver to improve its shininess and resist tarnishing, which is important. It is also involved in a Guinness World Record, not for its elemental nature. I don't think they give Guinness World Records for elements, otherwise hydrogen would have one for being the lightest element. Sir Paul McCartney in 1979 was the best-selling singer and songwriter, and he was given a rhodium disc. So if you like the Beatles, which I think most people do, I think they're okay. Rhodium can go in C. Next up is palladium. It has a London theatre named after it for some reason. I could Google that as to why, but I don't care. So palladium, if you like the London Palladium, I've been there once. It's nice inside. Maybe it should get bonus points for that. Its largest use today is in catalytic converters, so it helps protect the environment somewhat from the toxic fumes pumped out of cars. Palladium membranes are also used to produce high purity hydrogen, and they're in carbon monoxide detectors. Carbon monoxide poisoning, very bad. I think most people's homes have a carbon monoxide detector in them, so you probably have some palladium in your house. It can go in B. Silver. Silver. It's going to be here somewhere. One of the nicer looking transition metals. I mean, we do wear a lot of silver. Silver also useful for killing werewolves as silver bullets. Silver is also, it has a sort of natural antibiotic action to it, so it's sometimes sort of within wound dressings there are silver-based components in them which can act as a sort of sterilisation to keep the wound sterile if you've got a dressing on them, which is very useful. So silver can go in the A section. Next up is cadmium. Makes me think of Project Cadmus from DC Comics. Nothing to do with that. Cadmium oxide is what was used to produce the black and white and the blue and green in CRT TVs. Other than that, I've written boring in my notes, so it can go in the D section for that alone. Indium is going to be... My goodness, maybe I should have rehearsed this beforehand. There it is. I knew it was in P element. Here it is, element 49. So we talked a lot about CRT TVs and how they use some of these elements up here. Indium is used in LCD TVs, so we've moved on a generation in TVs now. So it is considered one of those technologically critical elements. It's also used as a soldering material, so if you do a lot of soldering, you probably have a lot of access to indium, and it is used in solar cells. So I think it can go in C. Why not? Next up is tin. Now, element number 50. Blind 50 tin. We've already talked about the other half of it, but tin plus copper makes bronze, so he gets bonus points for that. Tin plated steel is used as food packaging because it's not very toxic, and we love that. However, some organotoxin compounds like cyanide do have tin in them. So whilst tin itself is considered non-toxic, use it to package food, cyanide obviously very toxic. So you know what? C for cyanide, tin can go in the C section. I guess that makes bronze as an alloy of copper and tin. If we were ranking the alloys, I guess tin would go in the B section. But we're not doing that. So antimony is next, which this video must be real thrilling to watch. Antimony, number 51. It's largest used as mixed with lead and tin. It improves rigidity. So even though lead bullets aren't really used these days, if back in the day of lead bullets, antimony would strengthen the lead bullets. In 1931, in the Guizhou province of China, antimony coins were used, but that was a terrible idea as antimony is quite a soft metal, so they weren't very durable and they were discontinued. But antimony is acid resistant, so maybe that's why they thought it would be a good choice for a coin. Also in ancient Egypt, it was used as an eye cosmetic. C for cosmetic, antimony. Next up is tellurium. It's here, element number 52. It's a technology critical element for use in solar panels and in thermoelectric devices. As someone that likes planet Earth quite a lot, climate change is something that we need to solve. Elements used in more sustainable energy get bonus points, so I think tellurium can probably go in the B section. People that are poisoned with tellurium, I've written here, produce dimethyl telluride, which is a garlic-like flavour, but unlike, say, your arsenics and your cyanides with tin, you actually need quite a lot of tellurium to fatally poison somebody, so I don't think you should lose too many points for that. It's part of Hoyle's agar. That's a microbiology thing, so you grow bacteria on agar plates, and there are different agars for all different sorts of things. So Hoyle's agar is a selective agar used to differentiate Corynebacterium diphtheriae from other organisms in the respiratory tract microbiome. So all the microorganisms that live in the respiratory tract. If you want to differentiate this Corynebacterium diphtheriae from all the others, you can grow a sample on this Hoyle's agar, which has got tellurium in it, and you'll just be left with that. So microbiology, yay. Tellurium is going in the B section. Now, you may remember, however long ago it was, time is meaningless now, that I talked about bromine being an orangey brown colour, but it shouldn't get too many bonus points for that. And that's because iodine, the next halogen, is orange. And orange is my favourite colour, so this is the halogen that gets the bonus points for being an orangey colour. It's an antiseptic. When I was in hospital a while, they would come up with these iodine swabs which you had to crack like a glow stick, and they would just rub you with a sponge and you'd get all orange like a Oompa Loompa. It's on the WHO's list of essential medicines, and that's because iodine is a crucial component of hormones from the thyroid gland. A lot of people are iodine deficient, so make sure you eat a lot of things with iodine in them. Iodine can go in the B section, although chlorine is here, and iodine is better than chlorine. But is iodine better than helium? You know what? I'm going to squeeze iodine in there. It's the best of the halogens, but not one of the best elements. Iodine going in the B section. Next up, another noble gas, xenon. So we already know where all the noble gases go. C, because they are boring. It was the first noble gas in which a compound of it was synthesized, a xenon hexafluoroplatinate. So that makes, I guess, xenon a slightly less boring noble gas. It's also used in tactical flashlights, but noble gases are boring. Other than krypton, for reasons explained earlier. So xenon is going there in the C section. Next up is cesium. We are back to the S elements. You can see the progress that we've made by how many more periods of elements we have to go. We've got 2 more periods of elements, that's 2 more rows of elements. Element number 55, cesium. So pure cesium reacts explosively if you put it in water. That's the same for a lot of similar elements like lithium and stuff, but cesium is considered the most hazardous. You put a little bit in water, big explosion. It was the first element discovered by flame spectroscopy. So you put different elements under the flame and the flame will change colour, and then you can measure the wavelength of the flame and that can tell you what is in the flame. So pure cesium was discovered by that method. C for cesium. Barium, element number 56. It's used to make green fireworks. We talked about other colours of fireworks. It's worth mentioning that barium makes green fireworks. In fact, it's the same reason that barium makes green fireworks that flame spectroscopy works. The elements produce different colour. So I also learned that there is an official gem of California. I don't know if other places have official gems. I don't know if Aberdeen here has an official gem, but the official gem of California is called benitoite, and it's a barium-based mineral. So if you are Californian, hooray for you and hooray for barium. Barium carbonate is rat poison, so that's a bonus. Barium can also go in C. Our first green element, our first F block element is lanthanum. Lanthanum carbonate binds phosphates, so if you have an increased level of phosphate in the blood due to kidney failure, giving people lanthanum is a good treatment option. It can help sequester some of that phosphate. So that's good. It's the first of the F block, so I guess it should deserve some praise for that. I guess. C. There we go. Next up, cerium, element number 58. So cerium dioxide is used to remove pigments from glass. So a lot of glass, due to the different impurities within the compounds that are blown to make glass, if you want to take the colour away, you can add some cerium compounds to remove the pigments. That is cerium dioxide. It's used as an industrial polishing agent as well. It's also considered a rare earth metal, but it's also the 25th most abundant element. It's stupid, it can go in the D section. Not a good start for the F block elements. Praseodymium is next up, element number 59. So the name praseodymium, I've written here, comes from the ancient Greek. I guess my pen was running out. It comes from the ancient Greek prasenes, meaning leek green, because praseodymium is a green element. Yes, my notes just fell on the floor. This is going to be quite a video because I'm not going to edit this out. This is just a time for us to get. Think of this as like a pre-recorded live stream. So it's a green element. That's great. And I'm not starting this all over again. So, look, I put a lot of work into this, all right? So, element number 59, it's called praseodymium. It makes green, leek green. I like leeks. They are good food stuff. So C for praseodymium. Element number 60 is neodymium, which I now have to find on my sheets of paper. Here we go. Here is the neodymium one. It's another lanthanide. So these are these elements here. The first part of the F block are all lanthanides, and we've hardly had riveting facts on these elements before. Neodymium is used in the magnets that make microphones and headphones and computer hard drives. If you scale up those magnets, neodymium is also used for electric motors in hybrid cars, which makes it, I guess, mildly more interesting than these ones. So I'm going to put it in the B section. Promethium, element number 61. Promethium 145 is the most stable isotope. You can see here we're starting to get some more radioactivity in our elements here, but Promethium 147 is the most useful. It's a luminous paint, and it's also used in atomic batteries. Natural promethium is very rare, so promethium is often made from uranium-235 by bombarding it with neutrons. So that's a lot of effort to get an element that is used to make luminous paint. The name comes from Prometheus, as you might imagine, not the Alien prequel film, but he was the guy that brought fire down from Mount Olympus to, and this was given this name. I've written here a quote, to symbolize the daring and possible misuse of mankind's intellect. Why it was given to such quite a dull element, I have no idea. And for that reason, I'm putting it in the D section. Next up is samarium. Like neodymium, it can be used in magnets. These magnets have the ability to go up to over 700 degrees and not lose their magnetic properties. It's also found in the flint part of many lighters, but smoking is bad, so samarium can go here. Element number 61 was promethium, so element number 62 is samarium. Element number 63 is europium, which I have to go digging through my notes again. Here we go. It has commercial applications, but they are very few. It was used in CRT TVs to make red, and is part of the anti-counterfeit stain on the euros. So a lot of notes, including here in the UK, you shine a UV light on them, and the reflective symbol that comes back shows it's a real, genuine note. For the euro, that reactive compound has got some europium in it, so I guess it can go in C. Why not? Gadolinium, element 64. It has unusual metallurgic properties. Adding just 1% of it improves the resistance to oxidation and the workability of iron, chromium and similar metals. Well, isn't that just thrilling? It was also used in CRTs to make green. It is also used as an MRI contrast dye, which is a bit more important than those other two facts. It's good for diagnosing brain tumours, because brain tumours can disrupt the blood-brain barrier, and gadolinium can't normally cross the blood-brain barrier, but if it does cross the blood-brain barrier, when you're having an MRI contrast crosses the blood-brain barrier, that's suggestive that you might have some sort of brain tumour, or at least some damage to your blood-brain barrier. It can go in the C section. Terbium, another thrilling lanthanides. It was used to produce colour in CRTs like gadolinium, coating the cathode ray tubes in a terbium alloy. A terbium compound would make a green colour. I wonder if someone has done a test. Which was the most green of greens? Well, they all used. I'm no expert in CRT televisions, but these F-block elements are very boring. So we're just trying to get through the day. It's used as a biochemical probe. That's useful. It can be used as an electrochemical fuel along with zirconium dioxide, which can operate at higher temperatures than a regular fuel cell. So that's good. Chemical fuel cells are quite important for quite intense chemical reactions to provide the energy that we need. So terbium gets points for that. But the fact that these F-block elements these are the elements that I have brought this whiskey here for. They're driving me to the brink of excitement. It can go in the C block. To anyone still watching, I thoroughly appreciate you. Next up is dyspropium, element number 66. It's good for high thermal neutron absorption, which makes it a good choice for nuclear reactor control rods. So that's how you switch off the reaction that takes place inside a nuclear reactor. So dyspropium is a good choice for making the control rods out of that. It's got increasing demand for its permanent magnetic properties as well. So neodymium, we talked about its magnetic properties, is up here. Samarium has got magnetic properties. In fact, a lot of these lanthanides have magnetic properties. It can go in C as well. Why not? Next up is holmium. And I've written here, it's just got one bullet point. Just like all the other lanthanides. There you go. Holmium is going in C. Erbium. Again, like all the other lanthanides, so you would have thought it's going straight in the D section, but no, erbium is going in the C section with these ones because it is a lanthanide with something more exciting to say, and that's that it's used in cheap jewellery and cheap sunglasses to produce a pink colour. Also, a large proportion of lasers in surgical lasers in the dental and medical worlds are erbium based lasers because they have a high enough energy to do the surgery part, but a low enough energy not to just blast a laser all the way through your body. They just penetrate the skin a little bit. So in fact, you know what? Erbium can go up here in B. Thulium, so its increase in price and rarity makes it less of an ideal choice compared to other lanthanides, but it is used in portable X-ray machines as it doesn't need extensive radiation protection. I mean, you can see here it doesn't have a radioactive symbol on it here. Thulium. It's also used to protect the euro from counterfeiting, just like europium here. And like erbium, it can be used for laser-based dermatological surgeries. So erbium is up here. I've given it props for that's used in surgeries. It's also element 69. Yep. So thulium goes in B. Ytterbium. It's used for its high stability in atomic clocks. High stability in atomic clocks. It's getting late here, and I said we'd be going on a journey. Turns out, tier listing the elements, bad idea. But we are ploughing on through and making this video nonetheless. So ytterbium, in 2013 a pair of ytterbium based atomic clocks were produced, and they were the most accurate atomic clocks of all atomic clocks produced. They were accurate enough that they would lose a second of time in the period of the age of the universe at that time. So that's one very accurate clock. It can also be used as a radiation source for a portable X-ray machine. So the fact that, you know what, one of these F-block elements has got to make it up beyond the B tier, and ytterbium, you have won that honour. You are going in the A tier. The last of the lanthanides is a transition metal D, a D block element, so no more green for a while. Lutetium, it's like all the other lanthanides, so it's going to go down here. It has little commercial use as it's similar to all the others, but it's more difficult to isolate, so that makes it more expensive. So why would you pick lutetium when you could pick any of the others. Lutetium-176 has been used in determining the age of minerals and meteorites though, so that's mildly interesting, but not enough to take out of the D section. Next up is hafnium, element number 72. It was discovered in Copenhagen, whose Latin name used to be Hafnia, and that's why it's called hafnium. Hafnium carbide is the most temperature-resistant binary compound. So that's a compound made up of just two elements. So hafnium carbide is a hafnium and a carbon. It has a melting point of almost 4,000 degrees centigrade, which is a pretty cool fact. So I'm already thinking hafnium can go somewhere here near the top. There was some hafnium controversy, and it's a YouTube video. YouTube videos love controversy. I've talked about controversies before. Elements with controversy get some bonus points. So it's a high energy hafnium-178 was thought that it could be used to construct X-ray weapons, but DARPA at the time, which is a US military research agency, deemed it highly unlikely. In fact, they deemed it impossible because to make a hafnium-based weapon, it'd be unfeasibly expensive. But the fact that the thought exists, hafnium can go in the B section. Next up is tantalum, element 73. It's another one of these technology critical elements. So it's got a high melting temperature, which means it's used to coat the inside of furnaces and in chemical reaction vessels. It's often used as capacitors in circuits as well, and capacitors temporarily store energy in circuits. I think tantalum can go in C. It's not one of the boring transition metals, but it's a transition metal. Tungsten is a transition metal people have heard of. It gets bonus points for that. It has the simple W from wolframite, which is a mineral, a ore of tungsten. It's also the heaviest element with a biological function, and that's it's used by bacteria and archaea to make aldehydes. But I was doing some reading. In fact, a paper about tungsten was telling me that tungsten compounds, a sodium tungsten compound, they were testing whether tungsten might have toxic effects on humans and whatnot. Turns out no, but sodium tungsten compound does make worms infertile. So there you go. Not expecting to learn that today, were you? Tungsten goes in B. Rhenium, element number 75. So nickel-based superalloys that contain rhenium were used in combustion chambers and jet engine nozzles and turbine blades, and jets are cool, so rhenium gets points for that. Its radioactive isotopes are often used in radiotherapy for liver cancer, and it's been tested for other possible cancer treatments as well. There was a novel pancreatic cancer treatment tested that contained rhenium, where the radioactive rhenium was placed inside a Listeria bacteria, and then this bacteria would deliver it to the tumour site, and so because it's got a microbiology bit, it can go in B. Osmium. Osmium alloys are used in the nibs of fountain pens. That's cool, isn't it? Fountain pens. I think everyone dreams of having a fountain pen, don't they? It's useful for electron microscopy as well, as osmium can stain fatty tissues as it reacts with the lipids that make up fatty tissues. But it also fixes them, so tissues are fixed. It means they're not moving anymore. So the most common fixative is some sort of formaldehyde derivative. But osmium also fixes things, and I like microscopy, so it gets points for that. It can go in C. Iridium, element number 77. Iridium gets a lot of bonus points because it's found in high concentrations in things that have come from space than they are in the Earth's crust. And the important thing about iridium is that there is a very high concentration of it in the Cretaceous Paleogene boundary within the the layers of the Earth's crust, which is a strong indicator that this layer was made by a giant asteroid meteor coming down from space and hitting the Earth 66 million years ago, killing all the dinosaurs. Everyone loves dinosaurs. Iridium can go in the A tier. Element number 78 is platinum. So I play a lot of video games, if you know me, and I play my video games on PlayStation, and I love collecting trophies. I know this is that we are going for really tangential reasons to place these elements, but look, there's a lot of elements. We were in 78 elements deep. We've got to come up with some good reasons, and the reason for platinum being, I don't know, a B tier element is platinum trophies in the PlayStation world are the best sort of trophies you can get, and that's because platinum is a precious metal. So there it is, element that can go in the B tier. It's a good catalyst for hydrogen-based green energy, and I don't know how this works, but in between 1889 and 1960, a platinum iridium alloy that was 90 platinum, 10 iridium was used to define what a meter was. Who determined that this length of this platinum iridium alloy was a meter? You know, if I'd cut this alloy in half, this tube of alloy, that's 50 centimetres, but what if I was there and was like, well, this 50 centimetres is a metre? Don't understand, but that's how a metre was defined for a while. Next up is gold, another precious metal, makes jewellery. It used to be used to determine how much currencies were worth. That's quite important. Less so in the modern world. We use, a more flexible system. It is used a lot in technology. In fact, it's estimated that 16% of the world's gold is actually found in Japan inside technology. It's interesting. There you go. It can go in B. It's got some mildly interesting facts. Mercury, the liquid toxic poisonous metal. A. There you go for that fact alone. In fact, interestingly, what I'd found out when researching this nightmare of video is that mercury is in tooth fillings as part of a compound called amalgam. So there was a bit of controversy where people were like, am I going to get mercury poisoning by tooth filling? Well, it turns out the mercury levels are not enough to be toxic to you. But if you are exposed to an MRI machine, the mercury levels in your body do increase a little, but again, not enough to be toxic. So don't worry, if you have a filling, you're not going to die of mercury poisoning. Next up is thallium, element number 81. Thallium sulfate is a banned rat poison. It's banned because it's odourless and tasteless, so it's risky for people with children or just people and animals and the environment. So thallium can go in D. Lead. Used to make pipes out of it, which is really stupid because it is a neurotoxin that damages the function of the nervous system and also affects the action of enzymes. So those Romans, we credit them for a lot of things, but they made pipes out of lead, even though lead poisoning was already sort of beginning to be described at the time. A more modern use of lead is in batteries, but lead batteries are worse than lithium-ion batteries, which we put in the B section, so it's got to be lower than that. There is some method to this madness. Organ pipes are a lead-tin alloy, and the ratio between the two can determine the pitch of the organ pipe. So lead can go in C for that fact alone. Next up, bismuth, element number 83. We've probably all taken some bismuth at some point as Pepto-Bismol, the biz in bismol is from bismuth. It can be used as a lead replacement. In fact, we talked about lead in bullets earlier. Bismuth is a common lead replacement in bullets these days, especially in lead shot for shotguns, for hunting birds and whatnot, because lead is poisonous, bad for wildlife. Bismuth, not so much. So it can also go in C with lead. Polonium. So you can look at all the elements we have left. What do they all have in common? They're all highly radioactive. So it's a highly radioactive metal. Probably the most famous thing people associate with polonium was used to poison Alexander Litvinenko all those years ago, which is interesting because polonium-210 is also found in tobacco, and that's been known since the 1960s, and yet people still smoke. It's a major contributor to the causes of lung cancer, polonium in tobacco. So for that reason, and the fact that it poisoned a man, it can go in group D. Astatine is next up, element number 85. It's the rarest naturally occurring element in the Earth's crust and has possible uses as a potential cancer treatment, but other than that, not particularly interesting. It can also go in D. Next up is radon, which is here, 86. It's a noble gas, so we thought it's going in this section, but it does get some bonus points for a couple of reasons. So radon is produced from the decay of radium-226, which is found in granite. Now, radium-226 and radon, both radioactive. So I live in Aberdeen, the Granite City. I also got cancer in Aberdeen. Are the two related? A social study might need to be done. But the biggest reason that I'm going to put radon in group B is that radon, on the Wikipedia page for radon, it says not to be confused with Rodan, the Godzilla creature. I like Godzilla. I like Rodan. Radon, you're getting bonus points for having a name that's similar to a fictional creature. Well done to you. Francium is next. We are on the last period of elements, everybody. This is it, the home stretch from element 87 to 118. Strap yourself in. We are gunning towards the end. Francium. It's the last element to be discovered in nature. All these other elements down here have to be synthesized in a lab. It's only really used for research purposes because it's fairly unstable and is quite rare. Only 28 grams of francium is estimated to exist in the Earth's crust at any one time as it decays and becomes the next element along in its decay chain. So for that reason it can go in the C section. Radium. Interestingly, I'm going to put radium in the S tier. Now, you may be wondering why I have done that. Have I had too much of this whiskey coke? Maybe. But when I was at school, and I cannot remember for the life of me why, I was obsessed with radium. Like, absolutely, I was wanting to know more and more about radium. I don't know why I was obsessed with radium. I don't know how the knowledge of radium's existence came to me, but I loved radium. It was used in toys, it was used in condoms, it was used as a cancer treatment, and the important thing about the radium cancer treatment is it was used as the treatment option for Henrietta Lacks, which is where HeLa cells come from. And if you're someone that's ever done any cell culture, you should appreciate who Henrietta Lacks is. Radium was also used in condoms. The fun thing about radium was that it used to glow in the dark. It had a sort of reddish tint as it glowed. Again, because it was radioactive. It was used in condoms. Now, maybe this is the best possible condom that exists. You only have to wear it, and then you'll be infertile after a while due to radiation exposure. Then you won't even need to wear a condom anymore because you can't have kids. So radium goes in the S tier for my childhood obsession with it. Well done, radium, and well done, radium, for giving me the energy to continue through this chore of a task that I have set myself. Actinium is the next element along, and we are back in the F block. Here it is. D. Thorium. It's used in the glass of high quality cameras and the lenses of microscopes. Now, I like microscopy, as I said before, so thorium gets some bonus points for that. It also has a possibility of a nuclear fuel, as it's more abundant than uranium, but there are some big challenges with using thorium as a nuclear fuel, especially some of the more dangerous nuclear waste products that it makes. But thorium can go in the C section. Protactinium is next. It's a scarce, highly radioactive, toxic element. It's mostly used for radioactivity research. If at all, it can go in D. Uranium is a radioactive element that people have heard of, and for that reason alone, no, not for that reason alone, it can go in the A tier. So uranium-235 makes for the best nuclear fuel. However, uranium-238 is the most common form of uranium, and that can be converted into plutonium, which is the most common nuclear fuel, and we will talk about it momentarily. Depleted uranium alloys are what armor-piercing bullets are made from, and in a less positive note, uranium-235 is the most simple nuclear bomb type to make. Yay, weapons. We talked about plutonium, and another element that can be used to make plutonium, plutonium-238, is neptunium, which is here. It can go in D because plutonium is much more interesting. So plutonium, here, it's a nuclear fuel like uranium. It's more commonly used than uranium for a reason I already touched on. It's more easy to produce. It was used as a nuclear fuel inside pacemakers before lithium-ion batteries existed. So I feel like it should go in the A tier, just above lithium here. Because having a nuclear-powered pacemaker sounds cool. It's also put in space robots as an energy source, this plutonium-238. Plutonium-239 is the one used in power stations, in nuclear power stations. And I'm a big proponent of nuclear power. I know it's got some major drawbacks, but in terms of immediate biological planetary damage, nuclear power stations are much better than your coal-based power station, so plutonium can go up here. Next up we have americium, I don't know. The only thing I know about americium, that's something I knew before researching this video, is this is the radioactive compound that goes inside smoke detectors. So there is a lot of radioactive waste of americium from smoke detectors that have been thrown away. That's why you're not allowed to open a smoke detector. They work by disrupting the decay of americium is what keeps the smoke detector from not going off. And if that decay is interrupted, the detection of that decay is interrupted, the smoke detector will go off. But it is more prone to going off than, say, an optical based smoke detector. Not all smoke detectors are made from americium, but it can go in C. Why not? Curium, we're now entering the phase of elements named after scientists. So Marie Curie, curium is here. It could be used as a in nuclear power, but it's considered impractical due to its radioactive decay, but it does naturally glow purple, which is mildly interesting. So for that, my sister likes purple. Curium can go in C. Berkelium is next. It's a radioactive metal. Cool. D. Californium. It's a radioactive metal. Surprise, surprise. But it's an actually useful one in that it's often used as a precursor to generate some of the higher weight elements. You fire some neutrons at it, it'll start to get bigger. It also releases neutrons, so it can be used to start nuclear reactors. Interestingly, if you're poisoned with it, it disrupts the formulation of red blood cells and then accumulates in the bone. So C for that, why not? Einsteinium is next. Yep, it's a radioactive element. It's the element with the highest atomic number, 99. It's actually been seen with a human eye. It has no real research use other than to generate higher weight elements like californium, but it has no cool toxicity based facts, so it can go in D. Fermium. It was first observed in the debris of the H-bomb in 1952, so great, I suppose. It's element number 100, which is exciting. It's the heaviest element that can be made by neutron bombardment. It's still going in D. Number 1. Number 101 is Mendelevium. I don't know why they waited for 101 elements to name an element after the guy that came up with this whole thing, the periodic table, but here we are. If you bombarded Einsteinium with alpha particles, those helium-4 particles, you could get Mendelevium. Great, D. Nobelium, named after Alfred Nobel. Cool, D. Lawrencium, named after Ernest Lawrence. He was the inventor of the cyclotrons. All these heavyweight elements wouldn't exist without Ernest Lawrence. D. Rutherfordium, another Ernest Rutherford. Yeah, D. All of these radioactive metals, they all are incredibly short-lived. They don't really have any use. They just exist because they exist. They're all synthetic. We've all made them. They're not found in the world. They have no use. They're all going to be down here at the bottom. Dubnium is next. There's a bit of a naming controversy with this one. So it's element 105, and it was first described in 1968, but it was not finally named until 1996, which is the year I was born, because there were many failed meetings between Russia and the US, who both were saying that they were the first to discover it, and IUPAC, which is the International Union of Pure and Applied Chemistry, that ultimately confirms the names. There were all these failed meetings, but then by this point other elements had been discovered. It was originally going to be called Bohrium or Niels Bohrium, or named after Otto Hahn, but no, we got to Dubnium. It's named after Dubna, which is a place in Moscow, the Moscow province, which is where it was discovered. It can go in C for that slightly amusing story about names. Next up, Seaborgium, named after Glenn Seaborg, nuclear chemist. Yep, cool. That can go in D as well. Bohrium, yep, it's a radioactive metal named after Niels Bohr. Hassium, named after the German state of Hesse, which is where it was discovered. Yep, that's brilliant. Meitnerium is next, and that was the first element. So we've got all these elements that are named after men, so Glenn Seaborg or Niels Bohr or something. So this was named after an Austrian-Swedish physicist, Elise Meitner, who was responsible for the discovery of protactinium. So that can go slightly above in the C category. Darmstadium was named after the German city of Darmstadt. Interesting. Rontgenium is named after Wilhelm Röntgen, who was the discoverer of X-rays. Thrilling. It's element 111. That's cool. Next up is Copernicum, named after Copernicus. Yep, thrilling. Neonium is named after Japan. So the Japanese name for Japan is Nihon. Neonium was discovered in Japan. Flerovium element 114 was named after the Russian physicist Georgy Fleryov. Thrilling. Moscovium, named after Moscow. Riveting. Livermorium is named after the city of Livermore, which is in California, which itself is named after the Californian ranch owner Robert Thomas Livermore. Yeah, that's also going in the D section. Tennessine. Interesting that they decided to call this one an EEN. That's probably the most interesting thing about it. It's the most recently discovered element in 2010. Great, it's named after Tennessee. And then Organesson is named after Yuri Organessian. This is the second element to be named after somebody that was alive at the time of the element's creation. So Organessian is one and Seaborgium is the other. And there you have it. All 118 elements ranked on a tier list. Unsurprisingly, it does have somewhat of a normal distribution, although it is slightly skewed to the D tier, primarily due to all my hatred for all these synthetic elements that exist for 2 minutes or less and have literally no function in the real world other than the fact that they exist. But hats off to Radium. Radium, you're going at number 1 here for providing me with some joy, both in my childhood and here now. Thank you for watching, and I'm sorry.